Good morning, everyone. Myself Niranjan Reddy, Assistant Professor, BITS Varangal. Today we will discuss isothermal transformation diagram. So this is also called time temperature transformation diagram or CC curves because these curves will be in the shape of C. So it is also called CC curves. So in this, the eutectile steel is heated above austenitising temperature and it is cooled in the oil or salt bath. It is nothing but heat treatment process. It is quenched so that austenite will be formed to martensite. So these are the different cooling curves: 1 2 3 4 5 6 7. So this is the beginning of transformation and this line indicates the ending of transformation. So in this range we have different cooling curves. So on the x-axis we will take time and on the y-axis we will take temperature. So we can observe here this is the temperature limits. So from here different cooling curves are formed. So when the eutectile steel is heated above the austenitizing temperature and when it is cooled, so different phases are formed. So this is the coarse perlite. So this cross hatched lines indicate the phase. So here the phase is formed. So first one, coarse perlite. So here the hardness is Rockwell C 15 and the next cooling curve 2, medium perlite, Rockwell C 30 and the next cooling curve will get fine perlite, Rockwell C 40. When the eutectile steel is heated above the austenitizing temperature and when it is cooled in the quenching medium, so here upper bayonet is formed. The Rockwell hardness C. The hardness is Rockwell C 40. So the cooling rate. So when at different cooling rates, these phases are formed. So next one, lower bayonet. So this one is we are getting Rockwell C 60. So this is the isothermal line, isothermal curve, because the temperature is constant in this here. So in lower bayonet. So next to cooling curve 5. So this is the martensite starting temperature and this is the martensite finishing temperature. So in this curve, so martensite is formed. So the hardness will be Rockwell C 64. So the next curve is this cooling curve is tangent to the nose portion of the CC curves. So this cooling curve is tangent to the nose portion of the CC curves. So which is nothing but critical cooling rate, and above this line also there is a chance of forming martensite. So this is the martensite starting temperature and this is the martensite finishing temperature. So hardenability of the steel, when the when it is the ability of the steel to form martensite throughout the section at a cooling rate. So it is called hardenability of the steel. In in some in some curves, in some cases, the surface of the steel may get hardened, but when we go from surface to the in center position, the hardness may be decreased due to due to the cooling rate. So when the steel is hardened throughout the section, it is called hardenability of the steel. So the martensite hardness is Rockwell C64. So these are the things we can observe from the isothermal transformation diagram or time temperature transformation diagram or CC curves. So these are the cooling curves 1, 2, 3, 4, 5, etc. So the cooling rate may be different. Here 0.1 degree Celsius per second, 5 degrees Celsius per second, 35 degrees Celsius per second, 100 degrees Celsius per second, 140 degrees Celsius per second, more than 140 degrees Celsius per second. So at different cooling rates, when the steel is heated and when it is quenched, there is a chance of forming different phases. When we get martensite entire section throughout the cross section, it is called hardenability of the steel. So these are the things we can observe from the isothermal transformation diagram. So here austenite is in the stable form. So above these temperatures 723 degrees Celsius and 910 degrees Celsius, and it is stable below the austenitising temperature when it is quenched or cooled, when it is heated or when it is cooled, rapidly cooled, the austenite will be formed to either cementite or ferrite or different phases. So here austenite is unstable. So these are the different curves, cooling curves, and where coarse perlite, medium perlite, fine perlite, upper bainite, lower bainite, and martensite are formed. So this center line indicates A plus F plus C. So here in this range, so along this line, so there is a chance of three phases: austenite plus ferrite plus cementite. So this is the beginning of transformation and this is the end of transformation where these cross hatched lines are there. So this indicates the phase for different cooling curves, and these phases or these materials, these phases will have different microstructure, and so this is brief about the isothermal transformation diagram. So we'll meet with another topic in the coming class. Thank you. Please do like, share and subscribe my channel.